Hi everyone, David Sinclair here. Thank you for voting me the Longevity Person of the Year. I'm greatly honored to receive this, given the previous recipients. I'm certainly in good company. I appreciate being selected out of the now thousands of people who are working in this field, and I'll do my best to honor that. In the next 5 or 10 minutes, I'll give you some views on what I think are some of the most exciting avenues that we're going down in this field, and also some worrying trends. And I also want to talk about some of the new research in my lab that's coming out. So let me start by talking about how I feel about the industry and where it's going. Well, I started working on longevity, going back about 30 years ago. I saw that there was very little science being done at a rigorous level in this field. A lot of talk about antioxidants, which really was the state of the art back then. We're really at a different place now, of course. 30 years later, we've got the understanding that there are genes that control aging, both the ones you're born with and also how they control the epigenome. We understand that these two parts of the information that are stored in our cells are actually manipulatable. We can modify them, we can change them. 80% of our health in old age is modifiable, largely through epigenetic means. And we also largely understand that there are things you can do in your daily life to slow down the ticking of that clock. And more recently in my lab, and started off with Hannum and Horvath, is the concept that you can read the DNA with a DNA sequencer and see the DNA methylation patterns and use that to have a much more defined measure of biological age. In my lab, we have a paper that is up online in bioarchives. We're aiming to get this published next year, on bringing the cost of those tests down to about $1 per test, which would be wonderful, because then we can all be testing our cheek swabs every week if we want to see how we're doing and track that over our lifespan. So really, we're in a new age. I often liken where we are to the days of the Wright brothers, where they know that they can fly, they can go for really as long as their gas tank will allow. And we're really at that stage now. We know we can control aging in the forwards and backwards direction. In my lab, we're doing this all the time. We can drive aging forwards in a mouse, 50%, 100%, and then we're learning to reverse that. And this is really, it's a new age of science, a new age of understanding our bodies, really taking control of our own health. And the reason that's important, and often, if I talk to people outside the aging field, it's a shock to them that medicine is based on treating the end stages of aging. And we give these names to different diseases: cancer, heart disease, Alzheimer's. But really, these are, for the most part, manifestations of the same process, which I believe is largely driven by the loss of information in the body, the so-called information theory of aging. But getting back to the policy and the planet, what is important for the world to realize is that sticking band-aids on the end stage of aging is not the way to go. Eventually, we'll have age reversal technologies that will take advantage of the ability to reset the body. But until then, until we're actually addressing aging itself, we're never going to get very far. We're going to be extending lifespan by maybe a few years at best. Even if we cured cancer today, we wouldn't be able to extend lifespan by more than a few years. So for us to have a really big impact, what we need to do is to develop medicines and educate the public that it's a lifelong process of slowing down the aging process, the ticking of that information loss. Later down the line, there are these hallmarks of aging, which many of us work on. There are at least 9 of those. And we've been also addressing aging that way by trying to slow those processes down. Ultimately, where I think we're going, what's super exciting is that knowing how these hallmarks of aging are developing, and again, my theory, my belief, my science in my lab is pointing towards one of the main causes being epigenetic changes and the loss of gene regulation. Now, what we're showing in my lab in this new paper that's coming out is that if you reverse the age of the epigenome and get that clock to go back and get the methylation patterns to go back, among other structures in the nucleus, you can actually get rid of age-related diseases. We showed in 2020 you could cure blindness in old mice and also mice with glaucoma. We could regrow optic nerves that had been crushed. And now what we're publishing is that we can reverse aging in other tissues such as the liver and the kidney. But what's most exciting about this new work is that we're able to test the information theory of aging more rigorously. We're able to disrupt the epigenome in an animal, in a mouse in this case. And now we've tested hundreds, actually thousands of these ice mice, as we call them, ICE, for inducible changes to the epigenome. And those mice age rapidly, and we can see those changes based on the clock. And we see all the hallmarks of aging happen. And we also see that the actual diseases of aging happen to those poor mice, and they live shorter. Now, where we're at in my lab is we can now control the aging process very easily going forwards and backwards. And we've now undertaken reprogramming, largely using Yamanaka factors, but increasingly using other chemicals that could one day be taken as a pill, that we can reverse diseases of aging. And we have work that we're writing up where we can reverse brain aging, take an old mouse or mouse that's got Alzheimer's disease, and we're increasingly able to reverse the age of that brain. And when we do that, those mice regain the ability to learn. What that means is, as I was saying earlier, is that the diseases of aging that we create medicines for specifically could really be tackled by just one treatment, an age reversal therapy, which we can now do in mice using gene therapy by turning on 3 genes that are normally only on in embryos. But increasingly, as I hinted at, we're learning to do this with chemicals. And we're now treating human cells that have senesced, reached their ultimate end stage of aging, and we're able to reverse many aspects, perhaps all of those aspects of aging in those cells. And what we're hoping to do is to use these chemicals to be able to reverse the aging process across the entire animal, and then eventually across the entire human. And that would mean that we could each go to our doctors or have a medicine sent to us and reset our age over a couple of months by about 5 to 10 years, and then keep repeating that process. And with the eye study, so I work with Bruce Cassander and his lab down at Mass Eye and Ear Infirmary here in Boston, and we're showing with them that you can repeatedly reset that tissue back to being young again. And in fact, that the only reason we can't go multiple times beyond 2 times is that the mice die from old age, but they have great vision when they die. So, I've covered the policy, I've covered a little bit of what's happening in my lab and this new paper that's coming out, being able to control aging forwards and backwards. But I want to also talk about what I see are the problems, the pitfalls that we face as a field and a community. Now, one of the major issues is currently is the economy. We have a real, if not a recession, a loss of funding for biotech, no matter what happens, no matter what we call it. It's getting pretty tough to get money for very early stage biotechs. And there's still a bit of money around, but those companies that are mid-stage, that are heading to the clinic or even in the clinic now, it's very expensive, of course. Each trial is tens of millions of dollars. My concern is that what sparked over the last 5 years, and there's dozens of aging or longevity companies out there, is that we're going to lose some of them. We may lose as many as half of them if the economy doesn't pick up in the next 2 years and the stock market does better, because these companies need to tap the public markets for the most part to be able to continue operations when they go big time into phase 2 and certainly phase 3. So that's my biggest concern right now, is to try and make sure that all companies know that it's not time to spend, it's time to hunker down. And, unless you have very rich funders and very generous funders, it's a time to be careful with that. The other thing that I see is that we're seeing an exodus of academic students heading into professorships like I am, I am a role model for. And that's a real shame. There's a lot of jobs out there in biotech, especially here in Boston, where you just can't compete for salaries. My lab salary is about half that of industry, sometimes even less when it comes to a bioinformatician. And so we're really seeing an exodus out of science and biology, which is a real shame. But balanced with that is some optimism. I am seeing a lot more young people get excited about aging research in a way that I had never seen before. And so that combined, I think, all in all, it's still going to be a good time for aging research, but we really want to have some changes at the government level where we're able to raise the salaries of those young people who are really despondent about their future prospects. It's really so hard to get a job like mine. There are thousands of young scientists who vie for jobs like mine, and of course, very few actually get there eventually. And what we need is a system where we can have people stay in academia, even if they're not full tenured professors. That would be a wonderful change, I think, for the long run, is to have these stages and stepping stones so that we don't lose scientists to industry for the long run. A big exodus happened in my particular field of epigenetic reprogramming, where Altos, the company funded in large part by Yuri Milner and some by Jeff Bezos and a little bit by Bill Gates, really just threw money at the problem and managed to recruit the majority of the professors in my field away from academia into their company. Now that's great. I'm not going to say that it's a problem having $4 or $6 billion infused into the field. That's fantastic. It's just that we lose something when scientists are taken out of the system and don't have complete academic freedom as part of this community. We've seen it done many times by other companies, and not successfully, by the way. So I really do hope that this current trend is going to be a great thing for the field, that industry is going to nurture science and allow scientists to thrive in a way that hasn't been done before, perhaps not since Bell Labs or Menlo Park and Xerox PARC as well. So getting back to where we started, it's a great privilege. It's a great honor to be able to receive this award. I greatly appreciate it. And I will do my best to be a prophet of what we all want, which is to encourage young people to work in the field, to encourage investors to invest in the field, and to continue putting out information that's useful to the public as well, so that they can live their healthiest, longest lives. The tools are out there. We don't even need new breakthroughs to extend lifespan by 15 years. If people just do the right things, that's already a given. But I think that 15 years is the minimum that we should be able to expect. With the breakthroughs that I'm talking about and those that are now in many biotechs around the world, we should be able to extend lifespan by many decades. And even a child born today can expect, even without these breakthroughs, to be able to reach 100 if they take care of themselves. Well, many people will be centenarians by the end of this century. For those of us who are middle-aged, I still think that the technology is going so quickly that we too will benefit from these advances, and we can also look forward, if we take care of ourselves and we stay alive so that we see these technologies in our own lives, we'll also be able to make it in a healthy way to 100. And I'll just finish by giving you an example of a ray of hope. My father, who many of you may know about or have read about in my book, Lifespan, he's now 83. He started changing his lifestyle in his 70s, and he's literally fitter, healthier, stronger, and happier than he was in his 50s and even in his 40s. And I can vouch for that. I knew him those days. And so he's been doing the right things. He's doing exercise. He's not eating as often as he used to. He's taking some supplements that I talk about, the ones that I take as well. He goes to the gym a few times a week, and he has a great social life. And so he serves as a beacon of hope of what we can all at least talk about and hope for the majority of people on the planet. By doing simple things, you can actually look forward to a long, healthy life. So that's where I want to end. I want to thank you all again for being here, for listening to this mini speech, and for giving me the honor of this award. Thank you very much, and have a great time.